Hey everyone, welcome back to my channel. So today I would be making a video on binary search, what it is and how it can be implemented. Alongside that, I will also be solving a very popular lead code question that is regarding sorting all zeros and ones in an array. So let's start. So basically giving you an idea regarding what binary search is, you guys basically need to know that as of in linear search, we start from the start or either from the end or either from the end of the array and we search across each element. That takes a lot of time and it becomes a lot inefficient. But what binary search does is that it directly targets the mid of the array and then it checks on the left hand side of the array and also on the right hand side of the array. And if it finds the following key value either on the left side or either on the right side of the array, so it just displays it to the user on what index is it, on what index the value is basically. So actually we would be using a two pointer approach over here, and I'll explain you as I further code this following searching algorithm. So let's start. So I would be now declaring the size of my array that I would be using, which in this case I would be keeping a random value, for example, array size of 6. Yeah, so now what I would be doing is that first of all I would be creating a function for take the input for the array. I would be naming as it void input, and in this function I would be passing the array along with the size of the array. Yeah, so to take the input from the user, I would be running a for loop that would run from I is equals to 0 till I is less than size, and we will increment it. And now for each iteration, it will ask the user to enter the value. Yeah. So now coming to our main purpose, which is to code the binary search searching algorithm. So as we would be returning the index or either the original value or located on the following index. So the return type would be an integer, and I'll name my function as binary search. And for my function, I would again pass the same parameters as I have passed in the input function, which would be the array and the size of the array. So now to basically target the middle index along with the starting and the last index of the array, I also need to define those indices uh, uh, in my code. So basically, as we all know, the starting index is always the zeroth index of the array, and coming on to the ending index of the array, it is always the index minus size. And uh, just a minute. Yeah, so now we also need to define the mid of the array. So the mid would be the start index plus the ending index, and we will divide it by 2. Yeah, so this should be the mid. And now what we need to do is that we need to run a loop in this array. We need to run a loop in this function such that what happens is that as soon as the user enters the value, what we need to do is that it needs to check either the value is directly located at the mid index of the array. If so, it directly returns the middle index of the array, and if it is located behind the middle index, I mean to say towards the starting index of the array, so it will just move the end pointer, the previous index to the and it will move the end pointer to be the previous index before the middle index. And above if the target is above the middle index towards the ending index of the array, so what will it do is that it will shift the starting pointer to be the pointer next to the mid pointer. So I will show you guys. We will run a while loop that will run while the start is less than or equal to n. And now, just a minute, we do not have to include the size of the array. We just have to pass the target. For example, in my case, I have kept an integer n. So now what we will do is that we will use if statements. Our first if statement would be that if the array's mid index is equals to the target entered by the user, so return mid. And now we will run another if statement that if the target entered by the user is we would say greater than the middle index of the array, so we will shift our start pointer to be the pointer to be the index directly after the middle index. So we will update our start pointer to be the middle index plus 1. And the last statement, which would be again an if statement, but we don't write if in such cases, we directly write an else statement. So the condition would be that if the target value is less than the middle index of the array, so we will now just update our end pointer to be mid minus 1. So this would be it for binary search. And now after all of this has been done, we also need to update our mid pointer so that it constantly gets updated and we don't have any problems. Otherwise, it will just be stuck at a place and our code won't work. And I also forgot to mention another thing, which is, and now the if the target is not in the array, we will simply return minus 1. I also forgot to add a thing that binary search only works for sorted arrays. It does not work for arrays which are not sorted. So this is a drawback. But what the best part is that it is a very efficient searching algorithm when it comes to searching an array that has a large data in it. So our main function, we would firstly initialize our array with its size, and now what we would do is that we will ask the user to enter the array elements, and then we will directly call the input function and we will pass it the array along with its size. And now what we need to do is that we need to initialize our target, which in the function's case was the integer n, and will ask the user to enter the number to be searched in the array, and the user will directly enter the target. So now what we need to do is that rather than directly displaying the result by calling the function, what I like to do is that I like to store the result in another integer variable, which in my case I would store it as integer result. So I will directly call the function, pass it the array along with target. And now what I need to do is that I need to run an if statement that if the index is not equals to minus 1, what we need to do is that cout element is found at what we can do is that element is found at index, and I will call it result. Yeah, also need to. Yeah, so this would be it for our if case. And now after that, what we need to do is that I can run an else statement to handle error case, which would be printing uh, the element is not found. Yeah, so this would be it. Nothing much. I need to replace the index of in the if statement with the target with the result basically. Yeah. So this is the code for binary search, and now I would just run the program to check how it works. Yeah, so I would be entering the array elements, which in my case would be assorted elements starting from 10, 11, 100 111, 12, 13, 14, 15. Yeah, so now as I have entered the elements, I would search for the element uh, number 14, and it would return on which index is it located. Yeah, so as you guys can see, it is located at the fourth index, which is absolutely correct. As on the zeroth index we have 10, on the first index we had 111, on the second index we had 12, on the third index we have 13, and on the fourth index we had 14. Yeah, so this is it for binary search. Now let me show you guys a relevant example for binary search. A very popular lead code question, which is to sort zeros and ones in an array. It's a pretty interesting exercise. So let me code it for you guys. Sort 0 1. Yeah, so as usual I would include, so basically a user would input numbers that would range from zeros to ones in any order. They would be in alternate forms or in any other form. What we need to do is that we need to sort them in such a way that all the zeros are at one side and all the ones are at the other side. So it's a very good exercise and a very popular lead code question. So what I would do is that I would not initialize the size right now. I would directly write the code for the function. I would name my function sort 0 1, and what I need to do is that I need to pass the array along with the size of the array. Yeah, so what I would do here is that uh, I would again use a two-pointer approach. So int left I would say would be 0, and the ending index again. By the way, it would be pretty much easy if I do it using the starting and ending pointers rather than using the left and right keywords. Int end is equals to size. Just a minute. Size minus 1. Yes, now what I need to do is that I again need to run the same while loop as I did in the binary search, but it would not be an equal to, it would just be a less than loop. It will start as less than end. What we can do is that we would increment the left index if we see, I mean to say, if we would increment the starting index by 1 if we see that a 0 is at the starting index of the array. So how would I do it? I would again run a while loop inside, and what I can do is that I can pass the arguments that if the array's starting index uh, is equals to 0, and what else we can do that, yeah, is if the starting index is also less than the ending index, what we will do is that we will increment the left pointer, starting pointer basically. And what we will do now is that if it is not the case, like for example if the array's ending index is equals to 1, and if the left index is again, if the starting index is again less than the ending index, what we can do is that we will decrement the ending index so that it sorts all the ones. So I will again run a while loop, and it would be if array's ending index is equals to 1 and the start is less than the ending index, what we can do is that we will directly decrement the ending index Yeah, so now what we need to do is that we need to swap the starting index and the ending index. So what I mean to say is that uh, I want to implement swapping in such a way that all the zeros are at the left side of the array and all the ones are at the right side of the array. So for that, I need to use an if statement that if the starting index is less than the right index, because we need the zeros to be on the left and we need the ones to be on the right side of the array. So if the starting indexes are less than the ending, what we need to do is that we need to swap the array's starting index along with the array's ending index. And what we also need to do over here is that we need to increment the starting pointer along with the ending pointers, because otherwise it will just swap the first elements and it will leave the rest of them. So now as our function is done, I think there is no error in our following function. I would now just write the code to print our array, and I would not ask the user to enter the elements of the array. I would directly pass an unsorted array. So to print an array, I will pass the array along with the size of the array, and I will ask the user. I will tell the user that the sorted array is. And now I will basically run a for loop, and we will print the array's ith index. Yeah, so this would be it. Now I will just write the code for the main function. So for the main function, I would declare the size of the array, and then I also need to initialize my array. So I would directly initialize my array with the elements, and the elements which I will choose will be in random order. For example, on the 0th index I will have 0, on the first index I will have 1. Again I would be having a 1 and again a 0, again a 0, and then the last index on the 5th index I would have 1. So what our function should do is that it should bring all these three zeros on the left side of the array and all these ones on the right side of the array. So from the 0th index to the 2nd index there should be all zeros, and from the 2nd index to the 5th index there should be all the ones. So now I will directly call my function sort 0 1. I will pass it the array, I will pass it the size of the array, and alongside that now I also need to call the print array function, um, and for this again I need to pass the array along with the size of the array. So now I will just return 0, and now let's see how our function works. Yeah, so as you guys can see, our function is working absolutely fine. We have all the zeros on the left side and all the ones on the right side. So this would be it for this tutorial on binary search, and following a very popular lead code example to use the two pointer approach, and basically the same idea of how binary search works. You could also try different problems, such as popular problems to find the first occurrence and the last occurrence of a following element in an array. And we could also sort all even and odd numbers in an array. So thanks for watching. Do like, share and subscribe.